Hello, so in today's video, we're just going to sketch a couple of examples of quadratic functions. So the best way to do this is probably just go through, as I said, two examples rather than try and explain the theory. So we'll just look at these two examples here. So the first example is y equals 2x squared minus 7x plus 3. And the second example is y equals minus 4x squared plus 10x plus 4. So we're just going to try our best to sketch those two quadratic functions. So the key point before we do this is just to realize or just to consider the a value with our functions. So I mean, this a value is obviously the coefficient of x squared. So a is the coefficient of x squared. So our a value here is 2, and our a value here is minus 4. So just by remembering what we know from GCSE maths, when the a value is bigger than 0, you get this U shape, and when the a value is less than 0, you get this upside down U shape instead, this upside down parabola. So it's always important just to consider the a values of your quadratic, so you get the shape of your sketch correct. So that's the first point to make. The second point really, or multiple points really, is that when you sketch quadratics, you really need to do four things. So you need to firstly, well, it doesn't really matter the order you do it in, but you just need to do all of these things. You need to identify the y-intercept. So the y-intercept is where the graph crosses through the y-axis. So in other words, where the y value when the x coordinate is equal to 0. And it's always going to be this constant at the end, this constant with no x's attached to it, essentially. So this is always going to be your y-intercept, this constant at the end. So for example, plus 3 here, and for example, plus 4 there. So that constant will always be your y-intercept. Because, and again, you can just test this out. When you substitute the x coordinate equals 0, because obviously the x coordinate on the y-axis equals 0, when you substitute x equals 0, this becomes 0, that becomes 0, this becomes 0, that becomes 0. So you're just left with your y value, your y-intercept value. So it's always going to be that constant. The next key point is we need to identify the roots. So the roots are basically just the solutions to the equation ax squared plus bx plus c equals 0. So the solutions to your quadratic equation when you set that equal to 0. I should have said equals 0 at the end of that. Yeah, so basically these values where the graph crosses through the x-axis, so the values of x when the y-coordinate equals 0, that they are the roots of a quadratic graph. So these are your roots here where it intersects the x-axis. So we need to find those just by solving the equation, as I said, ax squared plus bx plus c equals 0. Point number 3, we need to identify the turning point as well. So yeah, so some of these quadratics, these ones where you've got a greater than 0, will have minimum points, and we've kind of illustrated that here. You get a minimum point there. And when you've got a negative a value in your quadratic, a negative coefficient of x squared, you get a maximum value up here. So this is when a is less than 0, your x squared coefficient. Yeah, so it's just key to make sure we identify that coordinate exactly, and obviously get the correct shape just by looking at the a coefficient. So yeah, let's start with this example here then. So y equals 2x squared minus 7x plus 3. So let's start by identifying the y-intercept. Well, this is going to be plus 3. So we know just by looking there that this y-intercept is plus 3. And if we wanted to really do the maths, we could just substitute 0 into that, 0 into that, and then we get y equals 3. So we know that the y-intercept will be 3. So let's just put 3 up there. So that's 3. We can plot that in. Now we need to find the roots of the quadratic. So we now need to solve the equation. So to do this, we solve 2x squared minus 7x plus 3 equals to 0. So where the y-coordinate equals 0. So we substitute in y equals 0, and then we solve this equation. That's how we guess our roots. So where the graph crosses the x-axis. So I mean, I guess you could use completing the square like we've done before. You could use quadratic formula to solve this. I'm going to try and factorize it. I think I can factorize it. Obviously, factorizing as well is another method that you can use from GCSE maths. So if we try and factorize this, I'm going to put a 2x there. I'm going to put an x there. So factors of 3 that add up to make the minus 7. Obviously, you've got this 2x as well there, so we've got to be careful with that. I guess if we put a minus 3 in there and a minus 1 in there, that should work. So minus 1 times by x is just minus x. and minus 3 times by 2x is minus 6x. Well, guess what? Minus 6x plus minus x is minus 7x. So that does work. Yep. And obviously minus 3 times minus 3 is positive 3. So this factorization does work. And so therefore we can say that the solutions will be as follows. So we've got 2x minus 1 equals 0, or x minus 3 equals 0. So we get our two solutions just by solving both equations. We get x equals 1/2, or x equals 3. So we're going to have a root at 1/2. Let's just put that there, 1/2. And we're going to have a root at 3 over there, plus 3. So great. Those are the two roots of the graph. And the turning point. So how do we get the turning point? So again, we just need to remember from GCSE maths that we can find the turning point of quadratics by completing the square. So we can use completing the square to find turning point, of quadratic. I mean, in theory, you could use differentiation and integration. Well, not integration, but differentiation. But I mean, if you've not already seen that, don't worry, because you will see differentiation later on in my future videos, because differentiation is a later topic in the syllabus. But in theory, once you know differentiation, you could use that technique as well to find the turning point. But you don't have to. The standard method that will work with a quadratic equation will be completing the square. So let's do that here. I'm just going to make the writing smaller. Yep. So then, okay, let's complete the square to try and get the turning points. So we've got this equation, 2x squared minus 7x plus 3 equals 0. Actually, so I'm not going to write the equals 0 there. Okay, what I can do, well, actually, yes, I will write the equals. No, actually, I won't. No, don't worry. Okay, right. So what I'm going to do is I'm just going to factor out a 2 from the first three terms. So kind of like what we did a couple of videos ago, where we completed the square on literally ax squared plus bx plus c. I'm just going to factor out the 2 from the first two terms, so x squared, and then a minus 7 over 2x to compensate, and then keep the plus 3 there. Obviously, if you expand these brackets there, you get back to the start up here. I'm then going to complete the square with these two terms on the inside. So make my brackets like this, put an x in there. I'm going to half this minus 7 over 2 coefficient. So half of minus 7 over 2 is minus 7 over 4 this time. And then square that result. And as always, I must subtract the square of this number here. So I must subtract the square of 7 over 4. So I must subtract that. And then obviously close bracket, and then add my plus 3 over there. Okay, so I get that. I'm just going to tidy things up a little bit. So 2 times by brackets x minus 7 over 4 all squared. I'm actually gonna just try and work this fraction out here. So 7 over 4 all squared. So that's going to be 49 over 16. And then close bracket plus 3. Okay, so we're nearly there. It's just going to be a case of expanding the square bracket that I've written there. So if we do that, we get 2 times by x minus 7 over 4 all squared. And then we're going to subtract 2 times 49 over 16. So that's going to be 49 over the number 8. And that's because 16 divided by 2 is the number 8. And then obviously this plus 3 over here. Again, I'm just going to tidy this up. So we've got 2 times by x minus 7 over 4 all squared. And then minus 49 over 8 plus 3. But that's just the same as 24 over 8. We've now got a common denominator. So 24 over 8 is just, well, 24 over 8 take away 49 over 8. So that's just going to be the same as negative 25 over 8. So as a final result, what we get is, I'll write this down here actually. So 2 times by x minus 7 over 4 squared, and then minus 25 over 8. Okay, so we've completed the square with this quadratic. What will our turning points be? Well, okay, so we know from GCSE that to get the turning point after completing the square, you take the negative of this number there, so you minus this number there, and you to get your x coordinate. So this equals the negative of your x coordinate And then this number here is literally your y coordinate of your minimum point. So you always copy that number there. And the reason is kind of to do with graph transformations and function transformations. For example, the f of x plus minus a transformation and the f of x plus a outside of the brackets transformation, those kind of things. We'll come on to that later in the syllabus. So you get a turning point of the negative of negative 7/4, which is 7/4, and you get a y coordinate of minus 25/8. So your turning point is going to be 7/4 and minus 25/8. So something perhaps like this here. So you get a turning point down there. Sorry, I'll do it in red again, just to keep it consistent. So you get a turning point down there of 7/4 minus 25/8. And then it's just a case of plotting this in. So we know it's going to be a positive U shape just because we got a positive A value. It's not going to be a very good sketch, but something roughly like this. I'm actually just going to move the X up a little bit. We just move this up. I'll try to at least somewhere there, let's just say. So yeah, then if you just sketch the graph, you get something perhaps like that. Again, not a very good sketch, but yeah, this coordinate there is just supposed to be this this 7/4 and minus 25/8 coordinate. So yeah, that's the sketch of this quadratic here. So obviously that's the x coordinate, sorry, the x-axis, that's the y-axis, and this is a sketch of y equals 2x squared minus 7x plus 3. Okay, great, so we've done that. Let's do example 2 now. So minus 4x squared plus 10x plus 4. And we'll do that here. So yeah, again, the y-intercept value is just going to be this plus 4 value here, so this constant at the end. So we know that when we sketch the graph, again, this is our x-axis, this is our y-axis, we're going to have a plus 4 intercept there. I'll just call that 4 there. Actually, no, I'll move it up a little bit, I think. Just move it up there. Sorry, a bit further up. Let's say there. Okay, cool. So you got that. Find the root. So again, it's the same procedure. So this time we're going to set our equation equal to 0. So set this equal to 0. I mean, everything, all of these coefficients are actually even numbers. So I'm actually just going to half everything. So minus 2x squared plus 5x plus 2 equals 0. And I'm actually going to multiply everything by minus 1 in this equation, just to make it a little bit more simple. So 2x squared minus 5x minus 2 there equals 0. Okay, great. So is there any way that we could factorize this? I don't think there is. I can't seem to see a way that we could do it. I'm just going to use the quadratic formula. So x equals minus b. So the a value here is going to be 2. The b value here is going to be minus 5. The c value here is going to be minus 2. So minus b is minus 5, which is 5, plus or minus the square root of b squared, so minus 5 squared, that's 25. Subtract 4 times a, which is 2, subtract times by c, which is minus 2, and then divide that all by 2 times a, 2 times 2. And so if we just simplify this, we get 5 plus or minus the square root of 25, and then so minus 4 times 2 is minus 8. Minus 8 times minus 2 is positive 16. So positive 16 plus 25, that's going to give us 41. So the square root of 41 in there, all divided by 4. So they would, so we now get the solution. So we get the first solution is 5 minus root 41 over 4. And then our second solution is 5 plus root 41 over 4. So root 41 is kind of between, well, it's between root 36 and root 49, so between 6 and 7. So yeah, this is going to be a negative. This first one's going to be negative because root 41 is bigger than root 5. Sorry, root 25, which is 5. So we're going to have one root here, let's say, and let's just say one positive root over here. So something like that. Yep, so we get our roots. And then our turning point, again, this is just going to be a case of completing the square. So we've got this minus 4x squared plus 10x plus 4. If we just factor out the minus 4 from the first two terms, we get x squared. and then minus 10 over 4x plus the 4 on the outside there. Again, I'm just going to make the writing smaller. Okay, so now then what we get is, again, just by continuing the process, so we get minus 4, and then we're going to try and complete the square. So brackets like that, copy the x there, half this coefficient minus 10 over 4. So half of minus 10 over 4 would be minus 10 over 8 this time, because 4 times 2 is 8. Then square that, then subtract the square of this number here. So the square of 10 over 8, and then plus the 4 there. And then it's just a case of tidying this up. So minus 4 times by x minus 10 over 8. I'm actually going to write this as, instead it's 5 over 4 instead, just because it's an easier thing to write. So, and then minus 10 over 8 squared, which is just the same as minus 5 over 4 all squared. 5 times 5 is 25. 4 times 4 is 16. So minus 25 over 16 there. And then plus the 4 here. So again, it's just a case of expanding the brackets. So we get minus 4 times by x minus 5 over 4 all squared. Minus 4 times by minus 25 over 16, just by expanding the square brackets. So that should give us positive 25 over 4, because again, 16 divided by 4 gives us 4, so we get 4 on the bottom instead there. And then, yeah, plus this 4 on the outside. Again, we can tidy this up a little bit. So minus 4 times by x minus 5 over 2 all squared, sorry, 5 over 4 all squared, I should say. And then plus 25 over 4. But 4 is just the same as the number 16 over 4. So we just get minus 4 times by x minus 5 over 4 all squared, and then plus 41 over 4. And so we get that that result there. And so what we can say then is we can say that we've got an x. So the turning point has an x coordinate of the negative of this. So this is equal to the negative of the x coordinate. And our y coordinate of our turning point is going to be this. So this is our y coordinate. So we know that the turning point, so turning point is going to be negative 5 over 4. So 5 over 4. And positive 41 over 4. So positive 41 over 4. So yeah, so we get that. And it's roughly going to be like somewhere, well, it's definitely bigger than 4. 41 over 4 is about 10. So somewhere maybe up here. So that's going to be our turning point. And because the a value there is negative, we've got a negative coefficient of x squared. It's going to be this like upside down parabola shape. So perhaps something like, this is an awful sketch, but perhaps something like this, and that's our maximum point up there. And then, yeah, maybe something more like that. Let me try and do that again. Something like that. I mean, you get the point. It should be something like that. And then you just move, if we just move this this coordinate, yeah, these are this cross to where it should be, somewhere like over here. It's quite hard dealing with this. Yeah, just somewhere over there, essentially. Yeah, that's going to be one of our routes, and another one of our routes will be over here, like there, and then we get a sketch like this roughly, and that's going to be our quadratic. Yeah, so that's how we would sketch this example. So hopefully that all makes sense. So it's just a case of finding the y-intercept, finding the roots, finding the turning point, and we can use completing the square, or also differentiation too, if you're aware of that technique. And then we can just plug in the numbers that we need and sketch the graph like so. So yeah, that concludes today's video.